Richard James will present Grade 4 Practice Paper 5, Part D. This Grade 4 numeracy project is given in 5 volumes, and we are at 5D, and we all know that each one is divided into 4 parts. Therefore, we are at the final video presentation in the final practice paper. This video presentation will be shorter than the other D videos because the written, or what we call the essay type questions, are not included. We will begin at problem number 37. Which of these shapes has corners that are right angles?
Option D.
Right, so Jerry is right onto it. And Jerry is saying that it is option D. Option D is surely correct. Right angles are the only angles that are marked in that special way, by using straight lines that are perpendicular to each other. The correct answer is therefore option D. When we see angles that are marked in this fashion, using line segments that are right angles to each other, then the marked angle is a right angle. Not only that, a right angle is formed by perpendicular lines. Perpendicular lines meet at an angle of 90
degrees.
Okay, so Jerry is saying 90 degrees. And since we have started this grade 4 numeracy, I have constructed, with the aid of Jerry Lewis, another angle cycle. And this is the angle cycle that we have. It is more detailed, and we have more relevant information included. So this is our new angle cycle, or just a part of it. As a matter of fact, we are taking a look at just 90 degrees, which is a quarter of a revolution of the entire angle cycle. So, beginning at 0, this is what a 90 degrees angle looks like. First we have our 30 mark, our 60 degrees mark, and then we have the 90 degrees mark, and there we have our right angle. The angles that have the same shape as the 90 degrees angle are all right angles. Notice the shape of this right angle. The ones that have the same shape, this one also, the one up here also, although they are not arranged in the same way, but they have the same shape, those are our right angles. All other angles are marked with curved lines, as in the other options. Notice that in the other options, the angles are marked with curved lines. So we have curved lines here, another curved line here, and this angle is marked with a curved line, and the one in the triangle is marked with a curved line. As we can see, only the right angles are marked with straight lines that are perpendicular or are at right angles to each other. Four students each drew one of the following shapes in a book. Which two students have similar shapes?
X and Z.
Okay, X and Z. Similar in mathematics means similar geometric features. and not that they are identically the same. So similar means that they have similar geometric features and not that they are identically the same. For similar objects though, the angles are usually identical. For example, those right angles in figures X and Z. So the similar objects are those of X and Z. And we have right angles right here, and we have right angles here and there. Is there anything else that is similar, Jerry?
The curve.
Right, so we have also that the curved portion is also on the other object. So we are sure that they are the similar shapes. They have the same shaped angles, and they also are accompanied by those curved lines. So the shapes in X and Z are the similar objects, and they are represented by option D. At this stage, your spatial awareness is coming into question. You should be able to look at objects and determine which of them are essentially the same. We also should be able to say that X and Z are essentially the same without dabbling with other objects. Option D is therefore correct. At this stage, finer details are not necessary. That is why the other objects are made obviously different from X and Z. So we are taking a look at grade 4 numeracy. At this stage, the finer details are not necessary. And we have among the shapes there, W and Y. They are really very obviously different from X and Z. So we have no difficulty in identifying the shapes that are similar. The table below shows the score 4 students got in mathematics tests for 3 terms. What was Bob's score in term 1? What was Bob's score in term 1? And Jerry is ready to tell me. What is that?
94.
And Bob scored 94 in term 1. How could we tell from the table that it is 94? Maybe it is obvious to some student, but we will take a look at how we can make sure to identify it. To find his score in term 1, locate the cell where the row of Bob's scores coincide with the column of term 1. So we are taking a look at Bob's score in term 1. So we need to take a look where the cell of Bob's row coincides with the cells of term 1. How do we do that? So we have highlighted all of the marks in term 1. All of those associated with term 1, we have highlighted all of them. There we have the column of scores in term 1. There we have the row of Bob's scores. All of Bob's scores are highlighted, and all of the scores of term 1 are highlighted. The correct answer is therefore option D. That is the reason for statisticians and other professionals who have to handle figures use of devices that order information. Information, especially numerical information, is better for analysis and calculation if it is placed in a table or used to construct graphs or charts. And of course, throughout this entire set of presentations for grade 4 numeracy, we have analyzed graphs also in order to get information, useful information from those graphs. So statisticians and other professionals make use of table and other devices that are used to order information in order that we might be able to get information or get a value or so from those tables or graphs in a very easy way. So sometimes it's just obvious, and sometimes we have to read into the chart or the graph. And no doubt when we have the information in a table, we have it at our fingertips, and we may find or make use of the relevant bit of data in a second. Which student's mathematics score improved over the 3 terms? Which student's mathematics score improved over the 3 terms? For an improvement, surely the student's score at the end must be greater than the score at the beginning. Is that right?
Yes.
Right. The score at the end must be greater than the score at the beginning. What do we notice? Compare the first and the third term score for the first 3 students. What do we notice? If we look at the first term and the third term in each case,
80s.
not only that, but we are taking a look at the improvement in the scores. Therefore, we need to take a look at which is greater or which is not greater. So it is the relative sizes of the scores that will play a very important role in answering this question. As a matter of fact, I'm saying that if we compare the scores for term 1 and the term 3 for those first 3 students, what will happen? We notice that the 82 is larger than the 80, the 85 is larger than the 75, and the 87 is larger than the 82. So we have a general improvement from term 1 to term 3. In each case, the third term score is larger than the score in the first term. There is therefore an increase in scores for all those students from the first term to the third term. Since all of those cannot be the correct answer, it means that if that is our approach, we could have misinterpreted the problem. So the problem says, which student's mathematics score improved over the 3 terms? And if we compare what happens in the first and the third terms, we will realize that all of those students, the first 3, would have shown that if we look at the first and the third term, that there is an improvement. And all of them cannot be the correct answer. So if that is the way that we are going to approach the problem, it means that we misinterpreted the problem. Instead of the word over, a more appropriate word may be throughout. Throughout. This would give the idea that there is improvement at every step or stage and be more in line with the requirement of the problem. So if we say throughout instead of over, then it might give the impression that we are talking about which one shows improvement at every step of the way. The student that satisfies the requirement will be the one who shows an increase from term 1 to term 2 and also from term 2 to term 3. Which student is that, Jerry?
Susie.
Okay, so Jerry is identifying that one already. So let us look at Carla's. For example, Carla's score increased from term 1 to term 2. Is that right?
Yes.
It does. But what about from term 2 to term 3?
There's a decrease.
However, her score decreased from term 2 to term 3. Her score did not constantly increase throughout the period. She therefore does not represent our correct answer. So, her score improved from term 1 to term 2, but did not improve from term 2 to term 3. And we are taking a look at the score that improved over the 3 terms, or maybe a more appropriate word would have been throughout. But whatever the interpretation of the problem is, it means that there should be some improvement at every step of the way. On the previous slide, we took a look at the characteristics of an incorrect answer. If there is any stage in which the score decreased, then that would represent an incorrect answer. Is there any stage in which the score decreased? If there is any stage in which the score decreased, then that would represent an incorrect answer. We can see that Susie is the student whose score increased throughout the period. Let us take a closer look at her performance. So right there, Susie's score increased from term 1 to term 2. Is that right, Jerry?
Yes.
Her score also increased from term 2 to term 3. Is that right?
Yes.
Right. Her score constantly increased throughout the period. She therefore represents our correct answer, and that is represented by option
A.
Right. The graph shows grade 4 and grade 5 students' favorite subjects. How many 5th grade students like social studies? How many 5th grade students like social studies? Now we have on our graph 2 sets of bar. What we have therefore is a double bar graph. So we have a double bar graph, and there is no doubt that we have the key to the bars right here. So the stripe bar is represented by what set of students, Jerry?
Grade 5.
And the completely dark bar represents which students, Jerry?
Grade 4.
Right. So let me ask you a question, Jerry. These students are from what grade?
Grade 4.
These students are from what grade?
Grade 5.
Right. So we may use the key in that fashion. To find the number of grade 5 students who like social studies, we first consider the bars for social studies. What are the bars for social studies? We have them right there. So we have social studies, and those are the bars for social studies. The bar with the diagonal strokes is for grade 5. And the completely dark one is for grade
4.
according to the key that we have right there. As we see in the key, we need the bar for grade 5. So we may forget about the other one. So how many 5th grade students like social studies? So we will focus on the grade 5 and we may forget about the grade 4. And Jerry is saying that it is 50. So we have over there, and we are highlighting that caption right there that says number of students. That means the axis that we have on that left-hand side is in reference, which is this vertical axis, to the number of students. So if we are attempting to find the number of students, then the number of students will have to be relative or in relation to this axis that we have on this side. So we need to measure the number of students according to the axis that we have there. The values on the vertical axis are in relation to the number of students. The value is 50 and it is represented by option
C.
Right, so we are at social studies and we are choosing grade 5, which is the striped bar, and we go to the height of the bar and go across to the axis which represents the number of students, and when we get there it is pointing on 50. Therefore the number of students associated with social studies is
50.
Is 50. We also have this problem that is related to the bar graph. Which subjects are equally liked by grade 4 students? Which subjects are equally liked by grade 4 students? And we know that grade 4 students are the students that are represented by the completely dark bar. So we may eliminate the other bars. According to the key, grade 4 students are represented by the dark bar. Those are the students for grade 4. So since we are talking about grade 4 students only, we may eliminate the other bars. So those are the bars associated with the grade 4 students. The subjects that are equally liked by grade 4 students are represented by bars that are of equal height. So the bars of equal height will be for the subjects that are liked equally by grade 4 students.
Mathematics and social studies.
Right. And Jerry is talking to himself.
Mathematics and social studies.
Right. So they are mathematics and social studies. They represent the subjects that are equally liked by grade 4 students. They are represented by bars of equal height. The bars of equal height are those of mathematics and social studies, and they are represented by option
C.
We could have found the number associated with each subject and identified the subjects of equal number. We are solving the same problem. Which subjects are equally liked by grade 4 students? The black bars belong to the grade 4 students. We may forget about the striped bars. Take note of the number associated with each bar. So we will begin. Take note of the number associated with each bar. First one down is reading. There we have it. And the height of that bar is 60. The next one is mathematics. The height of that bar is
70.
The next subject is English. And the height of that bar is
40.
Right, 40. Any other?
No. Science.
Right. And the height of that bar is
30.
Do we have any left?
Yes, social studies.
Right, we have social studies left. And the height of that bar is
70.
Those of equal numbers are mathematics and social studies. They are represented by option C. Let us magnify the expression that we have there. So the expression that we need to find the value of. If P is equal to 12, what is the value of P plus P plus P? So magnify the expression and make use of it right there. P is equal to
12.
It is equal to 12. Because P is equal to 12, we may write 12 in the place of each of those occurrences of P. This is called substituting 12 in the place of P. So we will make what in mathematics is called a substitution, in which we replace a variable by a particular value. And the variable in this particular case is P. And the value that the statement of the problem says that P has is 12. Therefore, where we see P, we may substitute 12. We're just writing the expression again so that it is always on the screen and we make our substitutions right there. So write the expression again so that when we do the substitution, we still have an occurrence of the original expression still on the screen. Make a substitution, make another, and finally. We will arrive at the answer by adding those three occurrences of 12. So if we add those three occurrences of 12, the result will be 36. When we add those three occurrences of 12, the result is
36.
And that is represented by option
D.
On the next slide, we will make use of the fact that if we add together three occurrences of P, then the result is 3P. The problem will be solved based on that fact. We will begin again by magnifying the original expression. There it is. There are three occurrences of P, and we may write that as 3P. P is equal to 12. Again, make the substitution, writing 12 in the place of P. The brackets serve two purposes. One, they prevent the numbers from looking like 312. If the brackets were not there, then it would look like 312. And two, in algebra, 3P means 3 times P. That should be transferred to 3 times 12. 3 is separated from 12 by making use of brackets. When numbers or expressions are written without any sign separating them, the operation that we assume is multiplication. So we have the 3 and we have the brackets which enclose the number 12. Between the 3 and the bracket, there is no arithmetic operation. So we do not see a multiply, a divide. We do not see subtraction or division. Therefore, since we do not see any sign, what is the operation that we assume, Jerry?
Multiplication.
Right, so it is multiplication. So 3 12s, 36. When we multiply, this results in 3 times 12, which is 36. And this is represented by option D. If H is 18 minus 6, what is the value of H, Jerry?
12.
So there we have H is equal to 18 minus 6. And Jerry was able to tell that it is 12. The result is 12. The sign that we have there is an equal sign. It means that the items on both sides are equal. Equal means that they have the same value. The value of H is therefore the same as the value of 18 minus 6. All that we need to do is to subtract 6 from 18, and the value of H is known. Right. So you do not have to count them as yet, Jerry, because each one of them will be numbered. And maybe at the end you'll be able to tell me the number of them. And the number of them is
18.
18 smiling faces. We have 18 smiling faces. If we cover 6 of them with sadness, like we have right there. So we have 18 smiling faces, and we are covering 6 of them with sadness. If we cover 6 of them with sadness, how many smiling faces are left?
12.
There we have it. Only 12 smiling faces are left. There are 12 smiling faces left, and that is represented by option C. We will continue with the solution of problem number 45. Jean saved N dollars last year and twice as much this year. How much money did she save in the 2 years? N dollars last year and twice as much this year. According to the highlighted section of the question, the amount of money that was saved last year is N dollars. So, for last year, we have N dollars. What about this year? We have it right there. Twice as much this year. Twice as much means 2 times as much, or double the amount. Whatever she saved last year, we need to multiply that by 2 in order to find the amount that she saved this year. She therefore saved 2 times N, which is the same as 2N. She saved N last year, and she saved twice as much as N this year. She therefore saved 2N. How much money did she save in the 2 years? How much money did she save in the 2 years? The amount for the 2 years requires that we add the two amounts together. So, N last year, 2N this year, and we need the amount she saved in the 2 years. So we need to put those together. Putting those together, we will add them. If we add N and 2N, the result is 3N. N plus 2N, 3N. The sum of N and 2N is 3N, and it is represented by option B. N means one occurrence of N, and 2N means two occurrences of N. Adding them gives 3 occurrences of N, which is 3N. We are taking a second look at the problem. This time we will put some figures inside there and make use of those figures in an analogy with the N that we have in the statement of the problem here. Let us use analogy involving a practical application to demonstrate how the problem may be solved. Let us say that the N dollars that was saved last year is $5. $5. The amount saved last year, $5. Twice as much as $5 is 2 times 5, which is equal to 10. So twice means 2 times. And at this early stage, we all know that when we use the word times, it is associated with multiplication. So 5 times, as a matter of fact, typically we call our multiplication tables times tables. So if you are talking about your multiplication table, we talk about our 2 times table, our 3 times table, our 5 times table, and so on. As a matter of fact, students don't generally say multiplication tables. They generally say times tables. So if she saved 2 times or twice as much this year, twice means 2 times, and the times is associated with multiplication. Therefore, the amount that was saved last year, we will multiply that by 2 or times it by 2 in order to determine the amount saved this year. So 2 5s, 10. How much money did she save in the 2 years? The amount for the 2 years requires that we add the two amounts together. So we will add those, 5 plus 10, and that's equal to 15. So the amount, if the N dollars represented $5, then 2N would represent twice as much as 5. 2 times 5. 2 5s, 10. And when we add 5 and 10 together, the result is 15. The 15 that we have there is actually 3 times 5. 3 5s, 15. So the 15 that we have there is actually 3 times 5. Where did we get the 5 from? Do not forget that $5 was given in the place of n at the beginning. We may replace it with n. So that amount of money that was saved, which is $5 in the beginning, last year amount. As a matter of fact, for last year, we have n, which is the same thing as $5. And we put that together with the amount saved this year. We got $15. And that $15 represents 3 times 5. But do not forget that the 5 that we use is, as a matter of fact, the same as the n dollars that was saved. So we may replace that 5 with n. We know that 3 times n is 3n. This confirms that our answer is 3n, which is option B. Which value of k makes the number sentence true? Where is that? There it is. There we have our number sentence, which says 4 plus 5 is the same thing as k plus 2, or 4 plus 5 is equal to k plus 2. There is your number sentence. We can immediately see that the left-hand side may be simplified, because all that we have on that left-hand side is 4 plus 5, which is equal to 9. So that left-hand side may be simplified. 4 plus 5 may be just replaced by 9. Therefore, that left-hand side is 9. So we have 9 is equal to k plus 2. Here is a simple question. What number do we add to 2 and the result is 9? At this stage, we need to understand that if a result was obtained through a particular process, if we need any of the values that we started with, all that we need to do is reverse the process. The process is addition. We may obtain the original value by doing the opposite of addition, which is subtraction. So these two numbers are added and the result is 9. In order to find out one of those numbers in the sum, or one of those numbers of the numbers that were added, we need to reverse the process of addition. The process of addition gave the result of 9. In order to find one of the original values that were added, then we will do the opposite of addition, which is subtraction. And the act of reversing a process in order to get to where we started from is something that students should be familiar with at this stage. And if not, then is a process that students should be familiar with or get to be familiar with. But at least the students should be able to understand that kind of an activity in which we do the reverse of a particular process in order to find one of the numbers that we started with, or to find original values. So 9 is equal to k plus 2. The result of adding k and 2 is 9. Therefore, in order to find what k is, which is one of the numbers that were added, then we need to do the opposite of addition, which is subtraction. 9 minus 2 is equal to 7. 9 minus 2 is equal to 7. So 7 is equal to k. It is not appropriate to have the value on the left-hand side. So when we have solved an equation, the symbol should be on the left-hand side, or the letter, and the value should be on the right hand side appropriately. It is not very good manners to solve an equation and leave it like this. So we will turn it around and we have k is equal to 7. The correct answer is option C. Before finishing up, let us take a look at some of the arithmetic operations that were performed in the latter part of the video presentation. We will begin by demonstrating that 12 plus 12 plus 12 is equal to 36, which we assumed but did not carry out the actual arithmetic process to prove. Begin by adding the 1. 12 plus 12 plus 12 is equal to 6. And then add the tens digits. 1 plus 1 plus 1 is equal to 3. And that's how we have 12 plus 12 plus 12 equals 36. On this occasion, we will carry out the actual arithmetic of subtracting 6 from 18, which we did physically but did not do arithmetically. Beginning with the ones digit, let us complete the subtraction process. So we will say 8 minus 6 is equal to 2. With nothing to subtract from 1, it returns as it is. So nothing to subtract from that one. And there we have our 12. Knowledge of 3 times 12 needed not be assumed. It is in our 3 times table and our 12 times table. Neither do we need to work it out, but here it is. We will begin the multiplication process as usual with our rightmost digit, the digit of least significance, or ones digit. So we did not actually need to multiply it out because we know our multiplication table. But let's go. 3 2s, 6. And then we say 3 1s, 3. And that's all there is to it. As a matter of fact, for the last 2 problems, Jerry took his leave. And as a matter of fact, there was no conversation between myself and Jerry. But we need to give Jerry a hearty thank you for his work throughout the entire 30 plus hours of mathematics videos. As a matter of fact, it's close to a day and a half consistently in terms of the consecutive hours that we have these videos running for. So for the last 2 questions right here, we did not have Jerry Lewis, but I'm really very thankful that for the rest of the mathematics videos and for the rest of the volumes that he really did a very good job.